This call is now being recorded.
Okay, so in this lecture, now we will discuss about the relation between all the three elastic constants. So all the three elastic constant means relation between Young's modulus E, modulus of rigidity G, or it is indicated by C, and bulk modulus K, and this is the constant parameter, that is mu. That means we have to prove that capital E is equal to 9 kg divided by 3k plus G. So this particular relation indicates that the relation between all elastic constant, because if you go through this particular relation here, the Young's modulus E is also there, then modulus of rigidity is also there, and K is also there. Okay, so this is the relation between all the three elastic constants. Now in the previous lecture we have derived the two derivation. The first derivation is for the relation between Young's modulus E and bulk modulus K, that is E is equal to 3k in bracket 1 minus 2 mu. And the second relation we have derived in the previous lecture, that is E is equal to 2g in bracket 1 plus mu. So by using this particular two derivations, whatever we have derived previously, by using that derivations only, now we are going to prove this particular equation. In the previous two derivations we have considered a1 cube. Then for the second derivation we have considered a rectangular bar ABCD. So like that structure we have considered, but for this particular derivation we need not require to go for any diagram. Only by using the previous two relations we are going to derive this particular relations. So we are having previous two relations, that is we have the first relation we are having, that is E is equal to 3k in bracket 1 minus 2 mu. Let us consider this is equation number 1. Then E is equal to 2g in bracket 1 plus mu. This is the second equation. So these two equations already we have derived. That is first equation, relation between Young's modulus E, bulk modulus K. Then second, relation between Young's modulus E and modulus of rigidity G. So these are the two relations. Now by rearranging the terms, let us see. By rearranging the terms in above relations. So from equation 1, what I will do, whatever the 3k is present at the right side, I will take to the left side. So it becomes E divided by 3k in bracket 1 minus 2 mu. So this is the equation number 3. Let us consider E is equal to whatever the 3k is present at the right side, that I have taken to the left side. Here it is multiply. So if I will take to the left side, it will get divide. Similarly, for the second relation, E upon 2g is equal to 1 plus mu. This is the equation number 4. So equation number 1 and 2 we have already derived. Equation number 3 and equation number 4 we have rearranging the terms and we have modified the equations. Now what is the next steps? So here we have to apply one condition, that is which condition we have to apply to prove our final relation. Then equation 3 plus equation 4 and multiply by 2 to equation 4. So what we have to do, we have to add equation number 3 and equation number 4 to each other, and for equation 4 only we have to multiply by 2. So what will be the next step if I will add equation number 3 and equation number 4? So in the equation number 3 and equation number 4, what are the left hand sides? So left hand sides are E upon 3k plus E is equal to E upon 3k plus E upon 2g is equal to, but what we have done, we have added equation 3 and equation number 4, but for equation number 4 we have to multiply by 2. So this is the term of equation number, sorry, E upon 2g or E upon g. Yes, E upon 2g. So we have added equation 3 and equation number 4, but for equation number 4 we have to multiply by 2. So this is E upon 2G. This is the term of equation number 4, so we have to multiply by 2. Similarly, left hand side we have added. Similarly, right hand side means 1 minus 2 mu plus 2 in bracket 1 plus mu. So this 2 means we have multiplied by 2 to the term of equation number 4. So this is the left hand side. Add equation 3 plus equation number 4 and multiply by 2 to the equation number 4. Similarly, at the right side, this is the equation number 3 plus equation number 4, that is 1 plus mu, and to that particular 1 plus mu we have to multiply by 2. Now at the left side, this 2 it will get cancelled, so you will get E upon 3k plus E upon G is equal to 1 minus 2 mu plus here 2 into 1 2 plus 2 mu. So you will get the final term E upon 3k plus E upon G is equal to 1 minus 2 mu plus 2 plus 2 mu. So at the right hand side, this is minus 2 mu, this is plus 2 mu, it will get cancelled. So modified step. So at the left side, at the denominator 3k term is there, at another side G is there, so denominators we have to make similar. So if I have to make the denominator same, so I have to go for the cross multiplication. So this is the 3kg, at the bottom side we have multiplied. So for this particular term, this is term number 1. Here we have done multiplication at the denominator side. Similarly, at the numerator side also we have to do the multiplication. So here the only 3k is present, so G is not present, so we have to multiply by G, that is E plus G. Similarly, for this second term, already we have multiplied by 3k at the denominator, so at the numerator also we have to multiply. Therefore E3k is equal to, here plus 1 plus 2, it becomes 3. So modified step. So in the left side, this E and E, this is the constant term, so I have taken outside the bracket. So E in bracket G plus 3k divided by 3kg is equal to 3. So this is the next step. Now as I have to prove the final relation in the form of E, so what I will do, I will write the equation, final equation in the form of E. So this E I will keep as it is. So here this 3 is as it is. So this 3kg, it is present at the left side and it is present at the denominator. If I will take it to the right side, it will becomes multiplication, that is 3kg divided by this G plus 3k. For 3k plus G, it is present at the left side at the numerator. So if I will take this term to the right side, it will get divide. So in bracket G plus 3k. Therefore E is equal to 3 into 3, that is 9 kg divided by 3k plus G. Or I can write the same relation, E is equal to 9 kc, because G is also represented by C, divided by 3k plus C. So this is the relation between all the three elastic constants. So whatever we have to prove, that is E is equal to 9 kg divided by 3k plus G. So what we have done, we are having the equation number 1 and equation number 2, that is previous two relations we are having. So by using that particular two relations, we have rearranging the terms, that is 3k and 2g we have taken at the left side, and then we will get the new equations, equation number 3 and equation number 4. Now for the further solution, what we have to do, we have to do the addition of equation number 3 and equation number 4, and to equation number 4 we have to multiply by 2. So here at the left side we have done addition, we have multiplied by 2. Similarly at the right side we have added equation 3, we have added equation number 4, and we have multiplied. Now here this 2 it will get cancelled. Here you will get some another term. Then in the next step, this minus 2 mu plus 2 mu, it will get cancelled. Then at the left side, what we have done? We have done that denominators we have made same. So for that, for making the denominator same, we have to go for the cross multiplication. So by using that particular cross multiplication, I have made all the denominators same. Then this e is the constant term which I have taken outside the bracket, and then finally I have written the final equation in the form of capital E, and then by rearranging the terms and after by making the some multiplication terms, I got the answer E is equal to 9 kg divided by 3k plus g. G plus 3k or 3k plus g, both are same. Therefore, E is equal to 9 kg divided by 3k plus g, or same equation I can write in the form of C, because G is also called as a C, or it is also called as a modulus of rigidity. Therefore, E is equal to 9 kc divided by 3k plus C. So in examination, sometimes a question will be asked, prove the relation between all the three elastic constants. All the three elastic constant means we have to derive this particular derivation. Or sometimes prove that E is equal to 9 kg divided by 3k plus g. So we have to solve this equation. Sometimes instead of using the g term, they will ask the question like that, prove that E is equal to 9 kc divided by 3k plus c. So we have to derive this particular derivation. So in this particular derivation, there is no any diagram, there is no any assumptions, only by using the previous two derivations and by rearranging the terms and by adding some of the conditions, we are deriving this particular derivation, that is relation between all the three elastic constants. Getting? Have you got this particular relation? It is very simple to understand. Only you have to rearrange the terms and add some of the conditions. Have you got this particular derivation?
Yes, sir. Repeat करें.
Okay. So now we have to prove the relation between all the three elastic constants. So what we have to prove? E is equal to 9 kg divided by 3k plus g. So for that purpose, we are using the previous two relations, whatever the previous two derivations we have derived. In that, the first relation is, this is the relation number 1. What is that? Relation between Young's modulus E and bulk modulus K. That is, E is equal to 3k in bracket 1 minus 2 mu. This derivation we have discussed in the last lecture. Then, second derivation also we have discussed in last lecture. That is, relation between Young's modulus E and modulus of rigidity G. So, E is equal to 2G in bracket 1 plus mu. So this is the equation number 2. Now for your further derivation part, what I will do, I will make some rearrangement in the equation number 1 and in the equation number 2. So in equation number 1, what I have done, whatever this 3k term is present at the right side, I have taken at the left side. So I got new equation, E upon 3k is equal to 1 minus 2 mu. This is the equation number 3. So this 3k term I have taken to the left side and it will get divided. Similarly, this 2g term, it is also present at the right side. Okay, so if this 2g I have taken to the left side, again this equation number 2 becomes E upon 2g is equal to 1 plus mu. This is the equation number 4. That means from equation number 1 and equation number 2, we have obtain equation number 3 and equation number 4. So this is the 3 and 4 equation. Now, for further derivation part, what we have to do, we have to add one condition. Which condition? That is, do the addition of equation number 3 and equation number 4. This is the first requirement. Do the addition of equation number 3 and equation number 4. And for equation 4 only, we have to multiply by 2. For equation 4 only, we have to multiply by 2. So from equation number 3 and equation number 4, this is the left hand side of the equation and this is the right hand side of the equation. So left hand side means E upon 3k plus E upon 2g. I have written E upon 3k plus E upon 2g, but we have to multiply by 2 to equation 4. So this is the term of equation 4. Which term? E upon 2g. ही कशाची टर्म आहे, इक्वेशन 2 ची आहे, तर आपण 2 न काय केलं, मल्टिप्लाय केलं. सो दिस इज द लेफ्ट हँड साइड. सिमिलरली राइट हँड साइड काय आहेत, 1 minus 2 mu and 1 plus mu. So I have done the addition, 1 minus 2 mu, this is the term, plus 1 plus mu, this is the equation number 4, and for this particular equation number 4 we have to multiply by 2. Okay, so I have done the multiplication. Now here at the left side, this 2 it will get cancelled. So I got the equation E upon 3k plus E upon G is equal to 1 minus 2 mu as it is, plus this 2 I have to multiply by inside the bracket. So 2 into 1 it becomes 2, and 2 into mu it becomes 2 mu. Okay, then second step, again once again as it is, E upon 3k as it is I have written, plus E upon G I have written as it is. So 1 minus 2 mu plus 2 plus 2 mu. So here minus 2 mu plus 2 mu it will get cancelled. So 1 plus 1 it remains 3. But now again for the further process, in the left side, left hand side, at the denominator 3k is present, and here also G is present. So what I have to do, I have to make the denominators same. So for making the denominator same, at the denominator side I have done the multiplication, that is 3k into G. So I have written 3k into G. But at one term only 3k is present, G नाहीये, त्यामुळे त्याच्या न्यूमरेटरला पण आपण G ने मल्टिप्लाय केलं, काय आलं, E into G. This plus term as it is. परत ह्या सेकंड टर्म मध्ये here only E is present but 3k is not there, so we have multiplied by 3k, that is you will get the E into 3k divided by 3k. G is equal to 1 plus 2 is equal to 3. Now in this particular term, this E is constant term at the numerator, here EG plus E3k. So this E I have taken outside the bracket. Bracket मध्ये काय राहणार, फक्त तिथलं E गेलं, so it will remains only G, plus 3k is only remaining, divided by 3k is equal to 3, or 3kg is equal to 3. Now finally I have to obtain my final equation in the form of capital E, that is Young's modulus. So this E I have taken at the left side as it is equal to, this 3 is also present right side at the as it is. Okay, now this 3kg term is present at the left side, and at the denominator side, if I will take this term to the right side, here it will get multiplied. Therefore 3 into 3k G, and this G plus 3k term is present at the left side but it is present at the numerator. जर मी ती राईट साइडला घेतली तर तिकडे काय होणार आहे, डिवाइड होणार आहे. So I have divided it. Therefore this is as it is, 3 into 3 9, therefore 9 kg divided by G plus 3k. That term I have written in the form of 3k plus G, and same equation I have written in the form of E is equal to 9kc divided by 3k plus C. So this is the final relation between all the three elastic constants. Now you got?
Yes, sir.
Yes, have you understood, all of you?
Yes, sir.
Yes, sir.
Yes, Rohit?
Yes, sir.
Okay. Others have understood this particular derivation. Very simple derivation is there. There is no any conditions, there is no any figure, there is no any assumptions. Only by using the previous two derivations, we have rearranged the terms. By making the denominator same, by adding one condition, we have derived this particular final equation. That is E is equal to 9 kg divided by 3k plus G. So this is the final relation. And these are the, in the previous lecture, we have derived the two derivations, and this is the third derivation from this particular chapter number 1. All the three derivations are very, very important. It will be asked for 7 to 8 marks as a derivation part or as a theoretical part. Sometimes problems based on this particular elastic constant, it is also asked for 7 to 8 marks, and maximum times based on this particular elastic constants and their relations, some MCQ based questions are also asked. Statement will be given to you, and below that 4 options are given in the form of formulas, and from that particular 4 options we have to choose the correct formula or correct option related to their respective relations. Okay, so this is the last derivation we have discussed today, and in the today's lecture in the morning and in this particular lectures we have derived the three relations, that is relation between E and K, relation between E and G. In addition to that, that mu is also present, and this is the last relation, that is relation between all the three elastic constants. Okay, so this is about the derivation part. Now we will solve the numericals based on the elastic constant. Okay, now we will solve the numericals based on the elastic constant. So this is the problem number 1 related to the elastic constant. Identify such types of problems, that is in the unknown parameters. In unknown parameters, they have asked find out the Young's modulus, find out the Poisson's ratio, find out the bulk modulus. Means we have to clear that particular problem will be based on the elastic constants or their relations. Now, first of all, I will read the statement and then we will check whether this formula is solved by which particular relation. Okay, a bar of 30 mm diameter, bar means it is circular in cross section, therefore it is having the 30 mm diameter, subjected to pull of 60 kilonewton. Pull means whatever the load is applied, that tensile load is applied, and whatever the load is applied, its magnitude is 60 kilonewton, and the major extension of length is 0.1 mm. The major extension of length is 0.1 mm for 200 mm length. So what happened? Due to this 60 kilonewton force is applied, the extension of that bar is taking place, and that extension is 0.1 mm, means change in length is 0.1 mm for 200 length. That means before application of load, its length is 200 mm, and due to the application of load, whatever its elongation is taking place, that elongation is 0.1 mm. Okay, full stop. And change in diameter 0.004 mm. What happened? Due to this 60 kilonewton force applied, change in length is 0.1, original length is 200 mm. Due to the same force, their diameter is also going to change, and that change in diameter value is given 0.004 mm. Full stop. Find Young's modulus, Poisson's ratio, and bulk modulus K. We have to calculate capital E, we have to calculate Poisson's ratio mu, and we have to calculate the bulk modulus K. Okay, so this is the statement. So first of all, according to the statement given, I will draw the figure. One bar I will draw. Okay, so this is the bar. It is having the diameter 30 mm. It is having length. It is having length 200 mm. It is subjected to the pull of 60 kilonewton. Pull of 60 kilonewton. Then, according to the figure and according to the statement, P is equal to 60 kilonewton is equal to 60 into 10 raised to 3 Newton. Length is equal to 200 mm. Delta L is equal to 0.1 mm. Then diameter is equal to 30 mm. Change in diameter delta D is equal to 0.004 mm, and we have to calculate Young's modulus E. Then we have to calculate Poisson's ratio mu, and we have to calculate bulk modulus K. So this much amount of parameters we have to calculate. Now, as we have to calculate the first parameter Young's modulus E, which relation I can use? Now first, if I have to calculate the Young's modulus E, which relation I have to use here?
Delta L
Which
is equal
one?
to PL upon E.
Yes?
Delta L is equal to PL upon
Delta L
E.
is equal to PL upon E, because what happened here, due to the 60 kilonewton external force, the 0.1 mm, this much amount of deformation is taking place. So we are having the deformation formula delta L is equal to PL upon AE. We are having the deformation formula delta L is equal to PL upon AE. So delta L deformation along the length, it is given how much? 0.1. P is given 60 into 10 raised to 3 into length is given 200 divided by cross sectional area pi by 4 into 30 square into Young's modulus is your unknown parameter. Now, if I will write the equation in the form of Young's modulus E, so E I will take to the left side, therefore 660 into 10 raised to 3 into 200 divided by, what is the cross sectional area? Pi by 4 into d square. किती येते cross sectional area? You do the
70
calculation. What is the cross sectional area?
706.85.
706.5 into 0.1. E I have taken left and 0.1 I have taken at the right side. Therefore, Young's modulus is equal to. Yes, Young's modulus.
16.97 16.97
How much?
into 10 raised to 3 16.97 into 10 raised to sorry sir चुकले थांबा सर
Yes, 116. 169.6 into 10 raised to 3 Newton per mm square.
Voice is breaking, sir.
Yes.
आवाज येईना सर आवाज ब्रेक व्हाय
You please mute from your side. Please check Young's modulus is equal to 169.76. Have you got? 169.76 or 169.97? 169.97, 169.76 into 10 raised to 3 Newton per mm square. So this is the Young's modulus E. Do the calculations. We have to use the deformation formula delta L is equal to PL upon AE. Now we have to calculate the second parameter mu, Poisson's ratio. What is the formula for the Poisson's ratio?
lateral strain to linear strain.
Formula for the Poisson's ratio mu is equal to. Formula for the Poisson's ratio mu is equal to.
Lateral strain upon linear strain.
Yes, lateral strain upon linear strain. Okay, therefore, now which will be the lateral strain and which will be the linear strain? In the figure, the force is applied along the length. So that means the force is applied in horizontal axis. So whatever the strain is developed in the direction of force, that strain is called as a linear strain. And the strain developed perpendicular to the direction of force, that strain is called as a lateral strain. So here in this particular figure, the force is applied along the length, means linear strain is developed along the length, means linear strain formula we can write, that is delta L upon L. And in the particular figure, the diameter is present along the vertical axis, that means along the y-axis, but force is not applied along the y-axis, but then also some amount of strain is developed. Force is applied in x-axis, and due to that force in x-axis, some amount of strain is developed in y-axis also, and along y-axis your diameter is present or length is present. Along y-axis diameter is there or length is there?
Diameter.
Diameter. The strain induced in the y-axis will be considered as a lateral strain means your delta D upon D. So I will put the value mu is equal to delta D. We are having how much? 0.004 divided by original diameter 30 mm divided by change in length upon original length means linear strain. Change in length 0.1 divided by original length 200. Therefore, mu is equal to, what is the value of mu? 0.2, 1.33 into 10 raised to minus 4.
0.26.
0.26.
26.
Sir, 0.26.
So 0.
Yes, 0.26 or 0.266. Do the calculations properly. First of all, do the calculation of lateral strain, then do the calculation of linear strain separately, and then you have to divide both the terms to each other. That is lateral strain upon linear strain. The ratio of lateral upon linear is called as a Poisson's ratio mu. Lateral strain upon linear strain is equal to Poisson's ratio mu. Now, third parameter which we have to calculate, bulk modulus K. How to calculate the bulk modulus K? Which relation we have to use? E we are having, mu we are having, so relation between E and K. Relation between
E and K.
E and K, that is
E is equal to 3K.
3K in bracket 1 minus
1 minus 2 mu.
Now put the values. Young's modulus 169.76 into 10 raised to 3 is equal to 3K as it is in bracket 1 minus 2 into 0.26. Now I have to calculate the final equation in the form of K. So I will write the final equation in the form of K. Therefore, 169.76 into 10 raised to 3 divided by 3 in bracket 1 minus 2 into 0.26. Therefore, K is equal to, what is the bulk modulus K? Do the calculations. Bulk modulus K is equal to
117.88.
117.88 into 10 raised to 3. 117.87 into 10 raised to 3. Unit is Newton per mm square. This is the bulk modulus K. Please check your answer. Bulk modulus K is equal to 117.87 into 10 raised to 3 Newton per mm square. This is the one constant. Therefore, we have to give the unit also, that is Newton per mm square. Yes, 117.88, then 87. Both answers are accepted. Do the calculations properly. Okay, finish.
Yes, sir.
Okay, so this is the first problem related to the calculation of Young's modulus, then mu, and then by using E and mu, we have calculated the bulk modulus K. Now, this is the second problem. Very simple. Please read the statement carefully first. A metal has modulus of rigidity 4 into 10 raised to 4 Newton per mm square. The metal has modulus of rigidity 4 into 10 raised to 4 Newton per mm square, and bulk modulus means K is equal to 8 into 10 raised to 4 Newton per mm square. Modulus of rigidity 4 into 10 raised to 4, that means capital G. Bulk modulus means K, 8 into 10 raised to 4 Newton per mm square. Find E and mu. We have to calculate Young's modulus E and we have to calculate Poisson's ratio mu. So these are the given parameters, that is G is equal to 4 into 10 raised to 4 Newton per mm square, and this is K, 8 into 10 raised to 4 Newton per mm square, and we have to calculate E and mu. So how to calculate? Please think about that. Which formula we have to use for our further calculation? Yes?
E is equal to 9 kg divided by 3k plus
E
G.
is equal to 9 kg divided by 3k plus G. Okay? So we have, why we have to use this particular formula? Because we are having the common relation between all the three elastic constant, and out of all the three elastic constant, two elastic constants are given. G is given and K is given, and from that G and K we can calculate the Young's modulus E. Therefore we have, that is E is equal to 9 kg divided by 3k plus G. Now only put the values. Capital E is the unknown parameter. 9 into K, 8 into 10 raised to 4 into 4 into 10 raised to 4 divided by 3 into, or you can write inside the bracket 3 into again K, 8 into 10 raised to 4 bracket complete, plus only G, 4 into 10 raised to 4 is equal to, Young's modulus is equal to, yes, 102.85 into 10 raised to 3 Newton per mm square. 102.85 into 10 raised to 3 Newton per mm square. This is the Young's modulus E calculation. We have used the common relation of the all elastic constant. E is equal to 9 kg divided by 3k plus G. This is the common relation. Out of the common relation, two elastic constants are given. And from that we have calculated one remaining elastic constant, that is E. Now, second, Poisson's ratio calculation.
E is equal to 3k.
Poisson's ratio. We can use any relation. Either we can use the E is equal to 3k in bracket 1 minus 2 mu, or we can use E is equal to 2j in bracket 1 plus mu. For example, E is equal to 3k in bracket 1 minus 2 mu. In that, E is given, K is given. We can use this relation also, or we are having second relation, E is equal to 2g in bracket 1 plus mu, because in this term also E is calculated, G is known, we can calculate the Poisson's ratio mu. Okay, so I will use any relation. For example, if I will use E is equal to 2g in bracket 1 plus mu, if I will use this second relation in the form of G, so what I will do, I will modify the relation E upon 2g is equal to 1 plus mu. So capital E is equal to, we have calculated 102.85 into 10 raised to 3 divided by 2 into G, means 2 into value of G, 4 into 10 raised to 4 is equal to 1 plus mu. Therefore, mu is equal to how much? 0.28. Please check your answer. 0.28 is the mu. You can use any relation. This is the relation number 1 we can use for further calculation. We can use this relation also for the mu calculation. E is equal to 3k in bracket 1 minus 2 mu, or E is equal to 2g in bracket 1 plus mu. So do the calculations properly. Take the unknown parameters at one side, remaining values at another side, and finally you will get the final answer in the form of unknown quantity. Please check mu is equal to 0.28 or not.
Yes, sir. 0.28.
Yes. You can calculate by equation E and K, or you can calculate by using equation E or G. So both the relations, you will get the answer same, 0.28. Others digits are same. Digit 3 or 4, it will be different. But previous 2 digits, it will be same, that is 0.28. Do the calculations properly. Yes, 0.28, it is correct. Others, please check your answer. Yes, 0.28, 0.28, this is correct. Yes, 0.28, this is the correct answer. Okay, finish. Have you finished the calculation part?
Yes, sir.
Okay. Now, this will be the last problem based on this particular type, that is related to the elastic constant calculation. Now read the statement carefully and we will solve this particular numerical and then we will stop. Okay. So read the statement. A metal bar 40 mm by 40 mm in section subjected to axial compressive load of 500 kilonewton. A metallic bar, it is having 40 mm by 40 mm in section subjected to axial compressive load of 500 kilonewton. Full stop. The contraction of 200 mm gauge length. Gauge length means length of that particular bar is given how much? 20 mm. The contraction, why it is contraction? Because whatever the load is applied, that load is compressive. Due to that compression, the contraction means change in length or decrease in length. It is found to be 0.6 mm. Full stop. The increase in thickness, is 0.04 mm. Increase in thickness is 0.04 mm. Full stop. Find the value of mu and all the three elastic constant. Means we have to calculate E, we have to calculate G, we have to calculate K. In addition to that, we have to calculate this mu also. Now please tell me, this 40 mm by 40 mm means which dimensions are given? Yes, 40 mm by 40 mm means
Cross-sectional
B and
area.
D.
cross-sectional area means which?
B and D.
B and D. B and D, because length, gauge length is separately mentioned in the statement. Therefore, 40 mm and 40 mm both are same, means 40 mm is equal to width B and remaining 40 mm is equal to thickness, which is indicated by small t, or sometimes it is indicated by D. Okay, here cross-sectional area as a given parameters. If I will write given parameters, so here small b is equal to small d is equal to 40 mm. Length is already written here, 200 mm. Change in length 0.6 mm. Then change in thickness means delta D is equal to delta D, or change in depth we can consider. Change in thickness or change in depth, which is equal to 0.04 mm. Okay. Change in length 0.06, change in depth or change in thickness 0.04 mm. Whatever the load is applied, P is equal to how much? 500 kilonewton, which is equal to 500 into 10 raised to 3 Newton. And we have to calculate mu, we have to calculate Young's modulus, we have to calculate K, we have to calculate, and G also we have to calculate. So if I will draw the figure to this particular section, this is the three-dimensional body. Okay. It is subjected to the compressive load. How much? 500 kilonewton. This side and this side. Length is given 200 mm. This is 40 mm width. This is 40 mm depth. And we have to consider this cross-sectional area for our further calculation. Okay. Now due to this particular compressive force, the length and width of this particular section goes on decreasing. But whatever this vertical distance is there, vertical depth, that depth is increases. Whatever the thickness is there, because applied load is a compressive load. Therefore, whatever the depth is there, that depth goes on increasing, but length and this particular width, goes on decreasing. Now, how to calculate the unknown parameters? Here also figure is there. This is 500 kilonewton compressive. This is 500 kilonewton. This is 200 mm. This is 40 mm. And this depth is also 40 mm. Now, how to calculate the first parameter, Poisson's ratio mu? How it is to be calculated? What is the formula?
Delta L is equal to PL upon
Yes, delta L is equal to
PL upon
Poisson's ratio. First Poisson's ratio we have to calculate.
lateral strain upon linear strain.
Yes, mu is equal to
Lateral strain upon linear strain.
lateral strain upon linear strain. Okay. Linear strain means the force applied along the horizontal axis. Please check. Force applied along the horizontal axis means the force is applied along the length. Means in the direction of length or in horizontal axis, your linear strain is there. But in remaining two direction, there is a lateral strain in the direction of Y and in the direction of Z. That means in the direction of width B or in the direction of depth D, there will be the lateral strain. Therefore, mu is equal to lateral strain means which parameter I have to consider? Whether I have to consider the change in depth or change in length for the lateral strain.
Change in length.
For the lateral strain, I have to consider the length or depth.
Depth.
We have to consider the depth because depth is present along the vertical axis, but force is not applied in the vertical axis. Force is applied in horizontal axis only. Therefore, in horizontal direction, there will be the linear strain. Linear strain means there is a change in length upon original length. And remaining lateral strain is equal to change in depth upon original depth. So we are having all the parameters. Change in depth is equal to how much? 0.04 divided by original depth 40 mm divided by change in length, how much it is given, that is compression 0.6 divided by original length 200. Mu is equal to, yes, What is the value of mu? Please check. Do the
0.33.
calculation.
0.33.
0.33. 0.33. It is the Poisson's ratio by using the formula lateral strain upon linear strain. Lateral strain means force induced in the direction perpendicular to the direction of force. Linear strain means strain induced in the direction of force. ज्या डायरेक्शन मध्ये फोर्स आहे त्याच डायरेक्शन मधल्या स्ट्रेनला आपण लिनियर म्हणतो आणि त्याच्या अपोजिट डायरेक्शन मध्ये जर स्ट्रेन येत असेल तर त्याला आपण म्हणतो लॅटरल स्ट्रेन. सो डू द कॅल्क्युलेशन्स. Change in depth upon original depth divided by change in length upon original length. Now, second parameter we have to calculate, that is Young's modulus. Capital E we have to calculate. Which formula I can use? Delta L is equal to PL upon E. Delta L is equal to PL upon AE. I can use this particular formula because delta L is given. Therefore, delta L is equal to 0.6 is equal to P 500 into 10 raised to 3 into length 200 divided by cross sectional area. Which cross sectional area I have to consider? Which cross sectional area I have to consider? L into B or B into D or L into D?
B into D.
B into D means here I will do the hatching. Here I will do the hatching. Force is applied in the horizontal axis. Therefore, this 40 means your B distance. This 40 means your D distance, means B into D, that is 40 into 40 multiplied by Young's modulus. Here A is equal to B into D. So tell me the value of Young's modulus. Do the calculations.
104.16 into 10 raised to 3.
104.16 into 10 raised to 3 Newton per mm square. This is the Young's modulus E. Now third, if I have to calculate the K, E I am having, mu I am having, I can use the relation between Young's modulus E and bulk modulus K, that is E is equal to 3K in bracket 1 minus
1 minus 2 mu.
Therefore, E is equal to, just now we have calculated, into 10 raised to 3 is equal to 3K is the unknown, 1 minus 2 into mu also just now we have calculated. So I can calculate the K. And similarly, I can calculate K is equal to 104.16 into 10 raised to 3 divided by 3 in bracket 1 minus 2 into 0.33. What will be the value of K? Please tell me the answer. And next parameter I have to calculate, that is modulus of rigidity G. So I am having equation E is equal to 2G in bracket 1 plus mu. So E I have calculated how much? 104.16 into 10 raised to 3 is equal to 2G in bracket 1 plus 0.33. Therefore, G is equal to 104.16 into 10 raised to 3 divided by 2 in bracket 1 plus 0.33. Therefore, G is equal to, yes, first of all, tell me the value of K. Yes, 102.11 is correct.
Yes, sir.
102.11 Newton per mm square. This is the value of bulk modulus K.
G, sir.
And G?
39.15 into 10 raised to 3.
Into 10 raised to 3 Newton per mm square. (39.15 into 10 raised to 3 Newton per mm square). Please check the value of E 104.16 into 10 raised to 3. Then bulk modulus K by using the relation of E and K. We have derived it. E is equal to 3K in bracket 1 minus 2 mu. We have kept the value of E, we have kept the value of mu and calculated bulk modulus K. Then second relation we have derived E is equal to 2G in bracket 1 plus mu. E we have kept, value of mu we have kept, and we have calculated the modulus of rigidity, or it is also called as a shear modulus. Yes, 102.12 into 10 raised to 3 Newton per mm square. This is the bulk modulus K. Bulk modulus K 102.11. And next relation we have derived capital G modulus of rigidity. Please check your answers. 39.15 into 10 raised to 3. Yes, 39.16 into 10 raised to 3 Newton per mm square. Yes, K is equal to 102.11, G is equal to 39.15. Multiply by 10 raised to 3. It is very important, along with their unit Newton per mm square. Okay, so these are the some sample problems related to the relation between elastic constants and their relations. So whatever the three problems we have solved, in that many times the deformation will be given to you, sometimes one Young's modulus will be given to you, forces are given, and we have to calculate the Poisson's ratio. Sometimes we have to calculate all the three elastic constants along with Poisson's ratio. Sometimes change in dimensions are given, that means original length is also given, change in length is given. Diameter, original diameter is also given, change in diameter is also given. In rectangular sections, original length, change in length is given, or change in depth, original depth, it is also given. By using that we can calculate the Poisson's ratio, and once Poisson's ratio is calculated, remaining terms we can calculate by using the relation of the elastic constant, that is E is equal to 3K and E is equal to 2G. So this is about the numericals based on the elastic constant. Only this much variety is there. Rather than this, there is no any other variety based on the calculation of the elastic constants. All of you have you understood this particular all the three problems? Same problem I have, it is there in your notes also. Some additional one or two problems are there, but it is similar to that only. Only values are changed and statement is changed. Otherwise, process it is same. Therefore, I am not repeating this particular problem. You just go through that particular notes. You can easily understood. Everyone, have you understood this particular three problems and the three missions? Yes, anybody is having any problem, please ask. Yes. So I think everybody is giving reply yes. It is very simple. Only we have to remind one Poisson's ratio formula and three formulas. So these three formulas are important for your derivations. It is important for MCQ questions. Also, whatever the three numericals we have solved, that numerical solutions also, these three derivations or these three formulas should be at your tip of tongue. Tone pattern झाले पाहिजे. Then you can solve any type of problem based on this particular elastic constant. Okay, so I hope everyone has understood, and with this particular last point and this particular last type, here we have finished the chapter number 1, that is based on the simple stress and the strain. So today I will send the notes. One PDF file is there. That PDF file I will send on your group just for your better understanding. Please refer that particular notes for your study. So for the attendance, I request all the students, please type your roll number in the chat box for the attendance. Don't type the roll number of your friend. Here I am observing all the chat box. So please don't type the roll number of your friend. So based on this particular chapter number 1, I will take one quiz related to the based on your objectives. That objective MCQ booklet also I will send. I will keep one quiz. That link I will send to you. You have to attempt the quiz in all respect. You have to go through this particular notes. In that, if you have not understood any part, if you have not understood any numerical calculation, please ask me anytime. Send me the message on the WhatsApp group. Send me the screenshot of that particular problem. I will give the solution of it. Or you can call me anytime. I will give the solution. Okay, with this, we will stop here. Please type your roll number in the chat box and leave the meeting.
सर
Yes.
कॉलेज चालू होणार का सर 15ला?
अजून तसं फायनल आलेलं नाहीये. आता 1-2 दिवसामध्ये फायनल येईल उद्यापर्यंत. किती मुलं बोलवायची किंवा किती % मुलं बोलवायची. It will depends on the university rules. Once university circular will come, then it will be sent to you all. Now you just attend the online lectures. If there is a call from your proctor teacher or CC, you have to report. You have to report. If there is a call from your CC, that is you have to attend from the home. You have to attend from the home.
ओके ओके सर.
Yes, those who are remaining, please type your roll number. Because once I will stop the recording, your attendance will not be recorded. Type immediately. Suyesh Londe, Katkar. Yes, Samadhan More, Shubham
केले
Katkar.
सर, टाइप केले.
Yes, yes. Yes, Shubham Katkar, have you typed?